Hey, what's up, guys? It's Pedro here from newcoder.com. And in this tutorial, we're going to be implementing a queue using an array. So to get started, we're going to create a class called queueArrayImplementation. It's going to contain a bunch of private data members. So front is going to be the index of the front of the queue. Rear is going to be the index of the rear of the queue. Number of elements is going to be the number of elements within our queue, and size is going to be the size of our queue. And here we have our queue array, and we're just going to use this to dynamically create our array. And next we have our resize method, and this is going to be invoked whenever our queue becomes full. And we'll take a look at the resize method later on within this tutorial. So now let's take a look at the one argument constructor. You can see that the size is being passed in, and let's say that the size for argument's sake is 8, for example. So now we move on. You can see that front and rear are both initialized to -1, and that's just to symbolize that the queue is empty because there is no -1 index. Next, we move on, and you can see that we're just setting the size down here. Afterwards, we're just going to dynamically create our array based on the size being passed in. And last but not least, you can see that we initialize the number of elements equal to 0. So before moving forward, I want to address what this is. You're probably wondering to yourself that this is a very strange looking array. And that's because this is a circular array. And a circular array is essentially connecting the beginning and the end of our array together. So these two arrays would be considered equivalent. They're just drawn differently. And the reason why we're using a circular array as opposed to a regular array is because if you use a regular array while implementing a queue, you're going to end up wasting space and memory. And that's because with a circular array, we have this wraparound effect. So to demonstrate this, let's say I have the following queue. And let's say I want to enqueue 9, for example. So if I was to increment rear for our regular array in order to enqueue 9, you would see that we'll be out of bounds because rear will be incremented to equal 8 and index 8 doesn't exist. So you can see that we've essentially wasted space within our queue. Now, let's move on to our circular array. With a circular array, we have a special formula to calculate the next index. So the formula is pretty simple. We take the rear plus 1 mod the size, and that will give us the index where we want to insert at. So 7 plus 1 is 8, mod the size, which is 8, will give us an index of 0. So now let's move on to the enqueue method. So you can see that we have data being passed in, and that's the data that we want to enqueue onto our queue. So the very first thing that we need to do is check to see if there's enough room within our array. So we check to see if the number of elements is equal to size. If this is true, that means there isn't enough room within our array, and we're going to have to call the resize method. Now, if we come down here, you can see that we're checking to see whether or not front and rear are both equal to -1. And that's because during our one argument constructor, we initialize front and rear to -1, and that's just to symbolize that our queue is empty. So if our queue is empty, what we're going to do is set both front and rear equal to index 0. Otherwise, what we're going to do is use the formula I showed you guys previously, and we're going to calculate the index where we need to insert at. Then, once we calculate where the rear index is, we're going to use that index to access that position, and we're going to assign it the value of the data. And since we successfully inserted within our queue, we're just going to increment the number of elements. Alright, so now let's actually give an example of the enqueue method in action. So let's say I want to enqueue 1 onto the queue. So first we check to see if the number of elements is equal to size, the number of elements is equal to 0, and the size of our array is 8, so that's not true. We go down to the next if statement. Is front equal to -1 and is rear equal to -1? The answer to that is it's true. So both front and rear are both assigned a value of 0. Then we come down here, we insert our data at position 0, and then we increment the number of elements within our queue. Alright, so now let's give one more example with the enqueue method. Let's say I want to enqueue 2, for example. So first, we check to see if the number of elements is equal to size. So 1 does not equal to 8, so we skip that if statement. We come down here. Is front and rear both equal to -1? It's not. We go down to the else statement. And here, we calculate the rear index where we're going to insert at. So right now, rear is at index 0. So 0 plus 1 is 1. Mod the size, which is 8. And that would generate the index of 1. Then we come here and we use the index to access that position within our array. And we assign it the data that we want to enqueue. And since we successfully insert it within our queue, we're just going to increment the number of elements. So now let's take a look at the dequeue method. So the first thing we're going to do is check to see if the number of elements is equal to 0. If this is the case, that means there's nothing within our queue, so there's nothing for us to dequeue. So all we're going to do is say that there are no more elements to dequeue, and we're going to return -1. Otherwise, if we reach to this point, that means there's either one or more elements within our queue to dequeue. So the very first thing we're going to do is save whatever data is within the front of our queue. Next, we're going to check to see if front is equal to rear. If front is equal to rear, that means there's only one element within our queue. So we're just going to set rear and front equal to -1. And if you remember from our one argument constructor, we initialized -1 to indicate that our queue is empty. So since there's only one element within our queue and we're dequeuing, that means our queue is going to be empty. So that's why we set it to -1. Otherwise, we come down here and we generate the new front index. And since we successfully removed from the front of our queue, we decrement the number of elements. And then we return whatever was in front of our queue. So now let's take a look at the dequeue method in action. So first we check to see if the number of elements is equal to 0. It's not. Number of elements is equal to 2. So now we come down here. So first we store whatever's in front of the queue. In this case, that would be 1. Now we check to see if front is equal to rear. It's not. So now we move on to the else condition. Now we generate the new front index. So right now front is at index 0. 0 plus 1 is 1. Mod the size, which is 8. And that will give us an index of 1. Then since we successfully dequeued from our queue, we decrement the number of elements. And then we return 1. That was previously first within our queue. So now let's give another example with the dequeue method. So first we check to see whether or not the number of elements is equal to 0. In this case, it's not, so we move on to the else statement. Now we just save what's in front of the queue. Once we do that, we come down here and check to see whether or not front is equal to rear. In this case, both front and rear is equal to 1, so it's true. So we set both front and rear equal to -1. And that's to signify that the queue is empty because we're removing the only element within our queue. Next, we come down here and decrement the number of elements since we successfully removed an element from our queue. And last but not least, we return temp, which is just 2, which was previously first within our queue. So now you might be wondering if having 1 and 2 within our array matters, even though our queue is empty right now. And the answer to that is no. So if we take a look at the enqueue method one more time, and enqueue 3, for example, is number of elements equal to size? It's not, so let's move down here. Is front and rear equal to -1? In this case, it is. So we set front and rear equal to 0. Now we come down here and insert at that position, and you can see that once we've inserted, we've essentially overridden the old data, which is why it doesn't matter if the old data is still there. And since we successfully inserted within our queue, we increment the number of elements. So now let's move on to our resize method. This gets invoked whenever we try to enqueue when our array is full. So first, we're going to create a temporary size variable, and this is going to be twice the size of our current array that we're using for our queue. Then we create an array that's twice the size of our current array, and this is going to be the array that we copy all our data to. Afterwards, we copy all the data from our old array to the new array. Now we can safely delete our old array. Once we do that, we can set our array to the newly created array. Afterwards, we have to set our front to equal to 0. And that's because when we were copying the data using our loop, we started at index 0. So we essentially shifted all the data. Then we set rear to index size -1. And that's because that would be the last index within our old array. Then we come down here and we update the old size to the new size. And last but not least, we're going to need a destructor. And that's because we dynamically created the array used for our queue. So all we need to do is call the delete method on it. So that pretty much wraps it up for our array implementation of a queue.